Hi again, everyone. Dr. Tom McNamara back for our course in college math, in prep for college math, rather. We are working on multiplying signed numbers. Now, as you can see from our illustrations with the chip model, whenever we multiply two numbers that have like signs, in other words, they both have the same sign, either both your factors are positive or both your factors are negative, then your product will be positive. If your numbers have different signs, then your product will be negative. Let's work out some quick examples where we apply those principles right here. Okay, so I'm looking at this first problem, 4 times negative 6. Okay, so my result will be negative. I have a positive number here, and I have a negative number here. So I have unlike signs. Product is negative. And of course, we know what 6 times 4 is. 6 times 4 is 24, so my result is negative 24. Okay, once again here, I see negative 45 times 37. So my answer will once again be negative. Unlike signs, product is negative. I'm going to have to do a little work to do this one here, because I got to do 45 times 37, but that's okay. And notice, all we're doing is building on what we already know with multiplication of whole numbers with this business of the signs, okay? So the fact that I got one positive and one negative means my result is negative, and to actually find the numerical part of my answer, I just do 37 times 45. So let's see, 5 times 7 is 35, carry a 3, 15, 18, so that's 185. 4 times 7 is 28. Carry a 2, so 1, 4. 5, this is an 8 here. I'll make that a little more clear. Right, because it was 4 times 7 is 28, so that's a 6. Carry the 1, another 6. So 1665. Okay? On your homework, on a problem like this, I am expecting to see this computation. Okay? I expect you to be able to multiply one-digit numbers in your head, but multiplying larger two-digit numbers like this, I'm expecting to see work here. Even something like this. So here my answer is going to be positive. Okay, right here. Like signs. When the signs are the same in both numbers, you will get a positive. So I have two negative factors, so my product will be positive. And once again, I am going to do a little calculation down here to get my answer. 73 times 4. 4 times 3 is 2. Carry the 1. 292. So my answer there is positive 292. Okay, so once again, I'm following my rules for signs to get the sign of the answer, and I'm using what I know about whole number multiplication to get the numerical part of the answer. So the fact that I have two negatives here is telling me my result is going to be positive, and then I do 4 times 73 to get the numerical value of my answer. I do want to talk a little bit about exponents with negative numbers. Or maybe we'll call it powers of negatives. We have, of course, talked about exponents or powers already in this course. It's repeated multiplication. And it means the exact same thing here. So negative 2 power 3, well, the power tells you how many times to multiply the base. So you're going to do 1, 2, 3 factors of negative 2. So negative 2 times negative 2 is a positive 4 because of the like signs. And then 4 times negative 2 is negative 8. Okay, so notice I took negative 2, raised it to the third power, got this. Okay, so keep that in mind. You know what exponents are all about. It's repeated factors. The exponent tells you how many times to put the factor in there. So 3 factors, because that's the exponent, of -2. So we are multiplying -2 times itself 3 times. And then we just go a step at a time, right? We do -2 times -2, get +4. Now you still haven't dealt with this factor of -2 yet, so that's why that's still hanging around. And by the end here we get a -8. Let's do a couple more examples of negative numbers with exponents. Let me do something like this. -3 power 5. Okay, so 5 factors of -3. -3 multiplied by itself 5 times. Okay, remember the exponent tells you the number of factors. The base tells you what the factors are going to be. So 1, 2, 3, 4, 5 factors of -3. All right, so first 2 factors of -3 multiply together to be a +9. Remember, we're following our sign rules. These 2 guys have like signs, the same sign. So the result will be a positive number. And now we just keep going down the line here. These 2, -27. Okay, 27 times 3, it's going to be 81, but I'll work it out here. 3 times 7 is 21, carry the 2, 2 times 3 is 6, plus the 2 is 81. These 2 guys are both negative, so the result will be a positive 81 times -3. And now we do 81 times 3, or sorry, 81 times -3. The resulting answer will be a negative because these guys have different signs. The 81 is positive, the 3 is negative. So the result will be negative, and it will be 243. We can check very quickly right here. 81 times 3. 1 times 3 is 3. 3 times 4 is 24, so 243. Okay, let's do something like this. Let's do -5 squared. Okay, now if you look at the previous 2 examples, I took a negative number to a power and I got a negative. I don't want it to give you the impression that that's always going to happen. If you take a negative number to certain powers, you will get back a positive. If we look at what squaring actually means, well, it means 2 factors of whatever the base is. So -5 times -5. These both have a negative sign. Rules for multiplying side numbers tell me that if I multiply 2 negatives, I will get a positive, and then positive 5 times 5, so 25. Let's see here. If I take -2 to the 4th power, -2 times -2 times -2 times -2, this will be a 4. A -8. And lastly, a positive 16. So, if I take a negative base, okay, if I have a negative base, if I have an even power, or an even exponent, my result will be positive. If I have an odd power, that means my result will be negative. Okay? So when you have a negative base, if you have an even power of that negative base, like we do right here, 4 is an even number. My result is going to be a positive number. So I really just had to compute 2 to the 4th in all this. Whereas over here, I had a negative number to a odd power. And look here, my result is negative. So that's just what we're summarizing down here. And I also want you to note the difference between two expressions that look very similar. Okay? It's something like this. It's negative 3 power 2 versus the negative of 3 power 2. Okay? So here, we're going to be following order of operations. We have to think back to the last chapter when we talked about order of operations. Parentheses, then exponents, then multiplying and dividing. Changing sign are at the level of multiplying. Okay, so you do any sign changes after you do the exponents, unless you're given parentheses here, which tells you to change the sign first. Okay, so this on the left means negative 3 times itself, negative 3 times negative 3, which is 9. This means the opposite of 3 squared. We're supposed to do 3 squared first, then do the opposite. So over here we would get negative 9. Okay? They look very similar, so be on your toes when you're dealing with problems that look like this. If you have this type of scenario, it's telling you to take this negative 3 and raise that to the second power. So we get negative times negative for a positive. Over here, you're doing the power first, then the multiplying, because changes of signs are at the level of multiplying. So the exponent would be done before the sign change. Okay, so just some stuff to keep in mind. I will scan these notes and post them to Canvas so you can review them and work on the assignment.